Alright, good afternoon. Algebra 2 Trig Honors class today. So I would like to talk about Chapter 5. So Chapter 5 is all about the rational exponents and using the properties of rational exponents, graphing radical functions, solving radical equations. So anything that's considered with radicals. So we'll talk about some of the property. Going back to Algebra 1, so the basic properties of exponents. So here's the following. We have for the basic properties of exponent. Record that we do have something like a to the power of m times a to the power of n. So that would be considered a to the power of m plus n. So the first one is called a product to sum. Okay, so product to sum. Or the other way that you just want to start out with the right hand side, then that would be sum to product. So the one on the left hand side, so we want to multiply the base, combine the exponents together. And then the other one is called the quotient to difference. So a to the power of m over a to the power of n. So that would be considered a to the power of m minus n. And then the third one is called the power of power. Okay, so the second one, quotient to difference. And then number 3, it's a power of power, so it's like a to the power of m times n. Okay, so power of power. Okay, excuse me. And now let's see what else that we have. And for number 4, we do have a product of power distribution. So let's say that you do have a times b to the power of n. So basically you can just distribute the power. And then number 5, we do have a quotient of a power. So again, for the power we want to distribute. So a to the power of m over b to the power of m. And then number 6, it's a zero exponent. So anytime they see the base, a constant base to any kind of, well, it's a constant base to a zero power, it's always considered 1. And then number 7, it's a negative exponent. So a to the power of negative n, it's considered 1 over a to the power of n. So now we're going to be using all this property, and then we try to use those properties to simplify the following rational exponents. There are 2 new properties that I need to introduce right here. So something that you guys probably never seen that in Algebra 1. So one of those is called the radical form to the exponential form. So radical form, we do have like n root of a. So the way to rewrite it is consider a to the power of 1 over n. So again, this form right here is called a radical form. And then we want to convert that to the exponential form. Okay, let me just rewrite that here. So exponential form. So that means you want to convert the number here as a reciprocal. So exponential form. So the number outside the radical is called the index number. So it shows how many times that you need to break down the base here. And also the other one, it's also considered a radical form to the exponential form, but this one involved with the power. So it's n root of a to the power of m. So this one, once you convert it to the exponential form, so it's a to the power of m over n. Okay, so now we're going to be using the following property to apply. Well, we just want to apply all this property for the expression here. So you'll see that in a minute. Okay, so number 2, 4, 6, 8. Those are the one that I'm going to show you here in just a second. So it's all about the properties of exponent, but you have to deal with the rational structure, which is the fraction. Okay, so now let's look at that number 2. So we do have m to the power of 16 to the power of 3 over 4. So what we can do here, we can use the power property. So property number 3. So power of power. So that means we can distribute that 3, 4. Multiply that by 16. And then this one here we can cross cancel. So we do have m to the power of 12. And nothing we can simplify from here, so that means the simplest form. And then 27, a to the power of 3, and then the whole quantity to the power of negative 1/3. As you can see, that's a negative exponent, the one outside the parentheses here. So what we can do, we can just convert that to the reciprocal form. So it's 1 over 27, a cubed, and then the whole quantity to the power of 1/3. And then from here, we can use that the exponential form. So from the exponential form, you can convert it back to the radical form. So it's 1 over cube root of the whole base here, 27, a to the power of 3. So one thing that we notice, cube root of 27, that's 3. And then cube root of a to the power of 3, that's a. So it's 1 over 3a. And then for number 6, so the base is 64, k to the power of 4, and then the whole quantity to the power of negative 1.5. So what we can do, we can always convert it to the reciprocal form. So it's 1 over 64, k to the power of 4. That negative 0.5, so the power turns out to be positive. So it's positive 0.5 or 1/2. Again, exponential form, we can always convert it back to the radical form. So it's 1 over square root of 64, k to the power of 4. So this one is considered 1 over 8, k squared. Okay, let me just rewrite it. So this one, it's 1 over the quantity of 8k squared. So again, using the properties of the power distributions, the properties of exponent, product to sum, quotient to difference, negative exponent, all that. Okay, so now let's do another one. Okay, let me just bring this down a little bit. Okay, number 8. And now what we got here, 81, k to the power of, x to the power of 6, and then the whole quantity to the power of 1/2. So again, this one can always convert it back to the radical form. So square root of 81, x to the power of 6. Again, if the index number is not shown, so that means here it's considered 2. It's a square root. So square root of 81, so then that'd be 9. Square root of x to the power of 6, x to the power of 3. So 9x to the power of 3. So now, what about something that's getting a little bit more complicated? So like number 10, 12, 14, and 16. So now to look at those following problem. So to simplify, your answer should contain only positive exponent with no fractional exponent in the denominator. So that means whatever the final form you have, so the denominator, make sure that there's no rational exponent in the denominator. Okay, so now to look at that. So normally people are using the process of what PEMDAS, parentheses, exponent, division, multiplication, division, addition, and subtraction. So you can always do it that way. And then, but also at the same time, you need to apply the properties of exponent. So you see that 4 right here, so we want to distribute. So we do have u to the power of 3/2 times 4. And then v to the power of 4/3 times 4. Denominator, so you want to compare the bases. Well, one thing that we notice, v to the power of 0 is always 1. So that one, you can just cross that out. And then the one with the same basis, so that means we can just convert that to the product to sum property. So this one can convert that with the sum with all the exponent. So what we got here is negative 3/2 plus 5/4 plus 4/3. So basically combine all the exponents together. So 3/2 times 4, so 2 goes into 4 twice. So it's u to the power of 6. And then this one, v, so that would be considered 4/3 times 4 over 1. Multiply the fraction straight across. So we do have 16 over 3. And then over the denominator, so combine those fractions together. So let's find the least common denominator of 2, 3, and 4, which is what? 12. So multiply by 6 for the first fraction. So we do have negative 18 over 12. And then the second one, we multiply by 3 top and the bottom. So we do have 15 over 12. And then the third fractions, 4/3, we do have well, just multiply by 4 top and the bottom, so we do have 16 over 12. So combine this all together, so eventually we do have positive 13 over 12. Okay, so u to the power of 13 over 12. Again, so simply just combine them. So negative 18 plus 15, then that'll be negative 3 plus 16, so 13. So 13 over 12. And one thing that you might be wondering, so what about the u, the one that we have top and the bottom? So this one can use the quotient to difference property. So it's a quotient, so that means we need to subtract the exponent. So it's u to the power, well 6 is considered 72 over 12 minus 13 over 12. And then v to the power of 16 over 3, nothing we can do, just leave it. So that eventually is going to be considered u to the power of 59 over 12. And then times v to the power of 16 over 3. Again, there's no more denominator here for the rational expression. So this one, you can just say that's over 1. So that means there's no fractional exponent in the denominator. So that means this one is the simplest form. The 1 is up to you whether you want to show that or not. And now, what about for number 12? Quite similar. So anytime they see like y to the power of 0, x to the power of 0, z to the power of 0, it's always 1. So we can just cancel that out. And now we do have x to the power of 2/3, because we want to distribute the power. 1/3 times 2, 2/3. And now the denominator, so combine the one with the same base. Combine the exponent with the same base. So x to the power of 1/3 plus negative 2. And then y to the power of negative 5/4 plus 4. So 1/3 plus negative 2, so it's 1/3 plus negative 6 over 3. So that one, so it turns out to be negative 5 over 3. Because you want to combine that 1/3. And then negative 5/4 plus 4, so 4, that's considered 16 over 4. So that would be considered y to the power of 11 over 4. Again, the one with the exact same base, so that means, well, it's a quotient, so we want to subtract those power. So 2/3 minus negative 5/3, so then that would be considered 7 over 3. So x to the power of 7 over 3. So the way that I come up with 7 over 3, because that it's a subtraction with the exponent. So 2/3 minus negative 5/3, so 7 over 3. And now, what about that y to the power of 11 over 4? Remember that according to the instructions, there's no fractional exponent in the denominator. So what we can do, we can find out the closest integer of 11 over 4. So the closest integer to 11 over 4, then that'd be 3. So in order to get that power to 3, so we need to multiply the top and the bottom of the fraction here by y to the power of 1/4. And a lot of people might be wondering, well, why do you need to multiply that by y to the power of 1/4? Because once I multiply the same base, what do you do with the exponent? Certainly you want to combine them. So 11 over 4 plus 1/4, then that would give you 12 over 4. So 12 over 4, which is what? 3. So eventually the final form is considered x to the power of 7/3, y to the power of 1/4, all over y to the power of 3. Again, for the denominator, there's no more rational exponent. There's no fractional exponent here. What about the numerator? Is that okay to leave that with the rational exponent? Yeah, that's fine. Okay, so for the fractional exponent, you can leave those in the numerator, but you're not allowed to leave any rational exponent in the denominator. So this one would be considered the final form. So now, what about for number 14? So that one is quite similar. So first thing that you want to do, so it's a negative exponent, so that means we can bring this one all the way down to the bottom. So eventually this one is written as 1 over x times y to the power of 3/4 to the power, the whole quantity to the power of 5/4. Again, the reason why that I take this all the way down to the bottom, because that it's a negative exponent. So anytime that you deal with the negative exponent, So that means you want to convert it to the reciprocal form. The reciprocal form. And now the rest of this, we just want to rewrite it. So x to the power of 5/3. And then y squared. So using that the rule PEMDAS, so started with the parentheses first. So that means you want to distribute the power. So 1 over x to the power of 5/4. And then y to the power, 3/4 times 5/4, then that'll be 15 over 16. Well, because that nothing can simplify, it's a power of power, so you want to multiply those powers. Again, that x to the power of 5/3, y squared. So we just want to carry those element all over here. And now, the one with the same base, compare and contrast the one with the same base. So multiplication, so that means we need to combine the exponent. So 5/4 plus 5/3. Common denominator is 12. So this one times 3 top and the bottom, so we got 15 over 12. This one times 4 top and the bottom, so we do have 20 over 12. So for the exponent of the base x, so we do have x to the power of 35 over 12. And then what about the one for the y variable, the y base? So 15 over 16 plus 2. So that one we do have 2 to the power. Well, just combine them. So 2 and what? 15 over 16. And this one certainly you can convert that to a mixed number because eventually we want to convert it to the integer exponent. So 35 over 12, so convert it. So that's almost 3. So it's what? 2 and 11 over 12. Okay, so this one, 35 over 12. Convert it. So it's 2 and 11 over 12. Okay, so now let me just rewrite that part right there. So convert all those rational exponent with a mixed fraction. So we do have x to the power of 2 and 11 over 12. And now for those you might be wondering things that we need to multiply top and the bottom in order to convert the rational exponent to its positive. So right here, so we want to multiply this one by x to the power of 1 over 12 and y to the power of 1 over 16. Well, the things that we want to get those mixed number to the closest integer. So the closest integer for this one is 3. The other one is also 3. So in order to go from 2 and 11 over 12 to 3, so we need to multiply that by x to the power of 112. Top and the bottom. So eventually we do have 1 over x to the power of 3. And then y to the power of 3 down the bottom. And then the top. So 1 times x to the power of 1 over 12. Y to the power of 1 over 16. So we just leave those element like that. Again, as you can see that the denominator, there's no more rational exponents. Okay, so that was 14. And now what about for number 16? So number 16 is quite similar. While the structure might be a little bit complicated, but pretty much you just want to follow through the same kind of process. So property that you can apply, you can always apply those property. Power, product to sum, quotient to difference, negative exponent, all those properties. So now for this one, let's just start it all with the top. Okay, so for this one here, we do have b to the power of negative 5/3 times b to the power of negative 4/3. So again, same base, multiplication, so that means we need to combine the exponent. So negative 5/3 plus negative 4/3, so we do have negative 9 over 3, which is negative 3. But let's put it this way first, improper fraction. So a to the power of 3 halves, so just keep it that way. And now denominator, so b to the power of 0, obviously that's 1. So 1 times a to the power 1/3 is just a to the power 1/3. So power of power, so basically what you can do, distribute. So a to the power 2/3. Because that's 1/3 times 2. So it's 2/3. And now the one with the same base and the one that with the negative exponent, so that means for that b to the power of negative 9/3. So I can just simply take that all the way down to the bottom because that's the reciprocal form. And then a to the power of 3/2, a to the power of 2/3, so it's a quotient, so that means we want to subtract. We want to subtract the exponent. So 3/2 minus 2/3. So 3/2 minus 2/3, common denominator is 6. So times 3 top and the bottom here. So we got 9/6 minus, multiplied by 2 top and the bottom. So we got 4/6, so it's 5/6. So the next part here, we do have a to the power of 5/6 all over b to the power of 3. And for those who might be wondering, do I need to rationalize? Do I need to multiply the missing base with the exponent top and the bottom? Well, there's no need to do that because this one here, it's already considered an integer exponent in the denominator. So to satisfy the condition of the instruction. So basically that just a to the power of 5/6 and then divided by b to the power of 3. And you guys can always check the work down the bottom. So down the bottom of the page here, so number 16. So that's what we found. And then 14. And then the rest of this. Okay, so now let's go back. Let's go to the next type of problem, solving rational exponent equations or radical equation. So for the lecture of chapter 4 here, I would like to break it apart with 2 parts. So the first half, second half, like what we did for the chapter 4. So the next type of problem is solving equations. So anytime they see the rational exponents, so for those you might be wondering, how do we solve for the equation with the rational exponent? Okay, so you'll see that. And also the rational exponent, this one can be written as a radical form. So another structure for this one is written as 216. So that equals the base, p minus 14. Well, I can just rewrite it as square root of p minus 14 to the power of 3. Another way that I can rewrite it, it's like 216. And then p minus 14, the whole base, to the power of 3. And then square root of the whole quantity. So that's just another structure, again, because they're both considered the radical form. So it doesn't matter whether you do the power first or you take the index number first. Now, but it's easier to solve it with the rational exponent. Well, the reason why I'm saying that it's easier because that once you get rid of the exponent, you will always notice that you need to multiply by the reciprocals of the exponent on both sides. So in order to convert the power to 1, so what I need to do, so I just want to multiply both sides, the power, by 2/3. Well, you might be wondering what's the power here. If the power is not shown originally, it's what? It's 1. So 3 cross out with the 3, 2 cross out with the 2, cross cancel. So now what's left here? It's p minus 14 on the right hand side. Again, rational exponent. So the way to deal with that exponential form, we can always convert it back to the radical form. So 216 to the power of 2/3 is written as cube root of 216 and then square. So cube root of 216, which is what? 6. Because 6 times 6 is 36. 36 times 6, that's 216. So cube root of 216, which is what? 6. And then 6 squared, 36. And then what we did here, we just convert that from the radical form or the rational exponential form to the linear form. See that right here? So it's just p to the first power. And then solve for p. So add 14 both sides. So that means p, what is that equal to? 50. Another thing you can always do, whatever the solution that you find out, you can always plug in the number back to the original equation. So 50 minus 14, that would give you what? 36. And then square root of 36, which is 6, to the power of 3, 216. So now let's do another problem. Number 20. Okay, so let me just erase this a little bit. Again, you can always deal with this one either with the radical form or the exponential form. But I do recommend you to do that with the exponential form. It's easier to find out the exponent that you need to multiply the reciprocal for. So now, 1016 equals p to the power of 5 thirds minus 8. So the first thing that you want to do, add 8 on both sides. So we do have 1024. So that equals p to the power of 5 thirds. And then 5 thirds, so that's the exponent. So we need to multiply the reciprocal. So the reciprocals of 5 thirds, which is 3 fifths. On both sides with the power. So this one got cross cancel. And then we're left with p. And that's what we need to solve. And a lot of people might be wondering, well, that's a big number. What's fifth root of 1024? To the power of 3. Now the things that you can always do either one of the power first, the power or the index number. But it's easier to reduce down the number first before you try to expand it. So fifth root of 1024, and that'll be considered 4. Because 4 times 4, that's 16. 16 times 16. And that's going to be a 3-digit number. Multiplied by 4 again, so that would be what? 1024. So 4 to the power of 3, which is what? 64. Well, let's see. 4 times 4, 16. 16 times 4, 64. And once again, you can always check the work by plugging the number back here. So 64 cube root, which is 4 to the power of 5, 1024. And then minus 8, 1016. And now this one's getting a little bit more complicated. But again, it just follows through the exact same kind of formation, the same kind of process. So again, any kind of separated constant, you always want to try to find a way to get rid of the number first. Subtract 1 first. So we do have negative 4 times the quantity of 6 minus x to the power of 3/2. So that equals negative 108. So two negative number, that means we're doing what? Addition. And then negative 4 divided by negative 4 both sides. So we do have 6 minus x, the quantity, to the power of 3/2. So negative 108 divided by negative 4, so then that would be considered 27. Again, 3/2, rational exponent, so we want to find the reciprocal, which is what? 2/3. So multiply 2/3 on the power. So 2 cancel, 3 got canceled. So we do have 6 minus x, so that equals 27. Cube root of 27, that's 3 squared. So then that'd be what? 9. So that means x, what is that equal to? So 6 minus what number equals 9? Minus negative 3. So it looks kind of complicated, but the things that if you're being able to follow through the instructions, the step-by-step process, so it's actually pretty straightforward. And then 24, quite similar. So the first thing that you want to do, subtract 6, because that's a separated constant. So it's negative 3 times the quantity of 2 minus 17p of the whole quantity to the power of 3/2. So 431 over 72. Well, this one, it's not reducible. Minus 6 over 1. So it's a big number. So this one, common denominator is 72. So 2 times 6, that's 12. 7 times 6, 42. 432. So once you subtract, we do have negative 1 over 72. So negative 1 over 72. Okay, let me just erase that, the previous part right here. Okay, so now the rest of this. Negative 3, divide it. I mean, you don't want to distribute because it's under the rational exponent. So divided by negative 3, both sides. In other words, you multiply by the reciprocal. So multiply by negative 1/3. So we do have 2 minus 17p, the whole quantity, to the power of negative 3/2. And now what we got here is 1 times 1, that's 1. Negative times negative, positive. So 72 times 3. So we do have 216. 1 over 216. So now, got to be careful with the negative 3/2. So in order to get rid of that negative 3/2, we multiply its reciprocals. So we multiply the power by negative 2/3. Okay, so multiply the power by negative 2/3. Both sides. Again, cross cancel. So we do have 2 minus 17p. And for those you might be wondering, what's 1 over 216 to the power of negative 2/3? So that one is just written as 216 to the power of 2/3. Again, negative exponent, so we need to reciprocate the whole thing. And then this one here is considered a cube root of 216. And then quantity square. So cube root of 216, that's what, 6. 6 squared, then that'd be 36. And then right here, so we just want to subtract 2 both sides. So we do have positive 34. And then solve for p divided by negative 17. So p is what? Negative 2. Again, you can always check the work, convert, just plugging a number back here. So negative 17 times negative 2, 34. So 2 plus 34, 36. 36 times negative 3, negative 216, to the power of negative 3/2. Well, that's going to be a number plus 6. So it's going to be a fraction here. So you can always check the work simply by plugging a number back to the original equation. And 24, the answer for this one. So just want to check that immediately. Negative 2. And that's what we found. Okay, going back. Okay, so now for the rest of this, so make sure that you watch the second half of the lecture on the second part of the video later today. Okay, so I'll see you guys next time. You guys have a great one.